Well, I wonder if I should just start a second YouTube channel completely devoted to fixing my own junk vehicles. The wife's Toyota left her walking. Luckily, it only left her walking from the house to the shop. I think we got a bad alternator. I'm not 100% positive. Here's the battery. Brought it in here and threw it on the charger. It's only 2 years old. Tag there says 1 of 18. And it's an AutoZone Duralast battery, which I'm not a big AutoZone guy, but I put one of these in her car once before. It lasted 5 years, and that was good enough for me, so I bought another one just like it. Anyway, it's been charging for a while now. Let's go ahead and test it. Now, I know a lot of shops are going to these Midico equivalent capacitance, fancy little battery testers with the little printout receipt and all that jazz. For my money, there's only one way to test a battery, and that's with a real carbon pile load tester. This is one from Autometer. Thing is built like a tank. It'll do 800 amps, so I can test a battery up to 1600 cold cranking amps. And it's got a built-in cooling fan. This thing is awesome. So that's a 600 cold cranking amp battery. So we're going to crank this thing up to 300 amps, and we want this voltage here to stay above about 9.5 volts for 15 seconds. So here we go. If we had a good connection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Nothing wrong with that battery at all. Alright, we'll do a quick check with the amp clamp here, hooked up to the positive battery cable. I guess I used to working on trucks and heavy equipment and stuff. The battery cables are just hilarious to me. I bet that's not even an 8 gauge wire. Might be a 10 gauge wire on that thing. It's just tiny. Anyway, we'll start it up and see what we get. Okay, headlights are on, high beam, rear window defrost, blower motor's on high. It's putting out 32 amps. Well, now it's putting out 42 amps, but it's only 12 volts. So the spec sheet says over 30 amps and around 12.1 volts. So we're low on voltage, we're okay on amps. Now that's at 2000 RPM. Okay, it's been running about 10 minutes now. We're down to 11.92 volts. Okay, with the headlights off, it comes back up to 12.3. Well, that sounds like a smoking gun to me. So that should have de-energized the alternator. And you hear it quiet right down. Well, I think we've built enough of a case here to say that this car needs an alternator. The problem is, it's not simple to make that call, because this is not like your granddad's alternator. So here's a schematic view of how the alternator works on this car. It is a computer controlled alternator. So it's going to use feedback from a current sensor. That's it right there on the negative battery cable. And that current sense information is going to feed back into the ECM, And then the ECM is going to use this RLO terminal on the alternator here to kind of vary the voltage set point of the internal voltage regulator. And it's all just because of fuel efficiency. I guess the idea is they can lower the system voltage from like a normal 13.5 or 14 volts down to something lower at under certain parameters, like at constant cruise speed or whatever. Gives them another 1/1000th of a mile per gallon or something like that. Anyway, it makes it much more complicated to diagnose this alternator. But the thing is, I don't think we have an issue here or here, because we saw the alternator is capable of putting out, 42 amps. So it's trying to do something. The computer is in control. It's just not getting what we need out of the alternator. It's not charging the battery, basically. It's not doing enough. Now, if that wasn't complicated enough, there's also a mechanical complication to this alternator. And I've kind of already pre-mangled it. That's not a normal alternator pulley. That is an overrunning clutch on the alternator. And you see there's a plastic cap over the end of it. I pretty much destroyed that getting it off. But I was pretty confident it was bad before I did that. You could hear it kind of rattle and make a racket. And then you see how rusty it is inside. So that thing is shot. So I don't know. I suspect we have either a bearing out inside the alternator, or this overrunning clutch is slipping, or a combination of both. And I think we might be missing one of the windings in the alternator, which is why we're not getting the amperage output that the computer expects. So it sends out a duty signal on that RLO wire, which that's part of that plug that I unplugged when you heard the thing quiet down. So I think, if I understand how the system works correctly, if we can remove this RLO wire from the alternator here, so we can basically depin that connector and get the RLO wire out of there, it'll basically default the alternator back to the old school style where the voltage regulator runs at a constant voltage. So it's always trying to charge the battery, fully. But I don't think we need to worry about that right now. I think we have a mechanical problem with the alternator, which requires it to be replaced. You can buy these overrunning clutches. It's kind of a special order item, but you can replace them. But I think rather than mess around with that, we're going to put a whole new alternator on it. Well, probably it'll be a reman because it's Sunday and she needs her car tomorrow, so I really want to get this fixed up for her. The car has 225,000 miles on it. That's the original Denso alternator, so it's put up a pretty good fight. I think it's time to make the call. A pretty spendy little guy, $200 for a reman. It's over $300 for a new one, which I would prefer to buy, but like I said, I cannot get that today. So that's my call. It needs an alternator, either because of the overrunning clutch or because of the alternator itself, or a combination of both. So this is a better look at that overrunning clutch. And it's supposed to spin freely in one direction and then lock up in the other direction. Hold on. So it doesn't seem to be doing either one reliably. Like sometimes it gets tight, but then you let off a little bit and it gets loose again. Like I said, the clutch is available. It even comes with a little installation tool to replace the thing, but it's a special order. It's going to take me probably a week to get the clutch. And I think it's about $80 for the clutch. And the whole reman alternator is about $210, maybe $200. So I think with this kind of miles, we just go ahead and put a whole alternator on it and go from there. Okay, one reman alternator. Not an easy item to find on a Sunday morning. I ended up having to get in the zone. It comes complete with a new overrunning pulley clutch gizmo, and supposedly it has a lifetime warranty, but I'm sure we won't need that because it says it's triple tested and approved and certified. So yeah, should be good to go. I did notice this little cheesy dust cap is already pre-broken, but that's okay. He told me they would warranty the alternator if this dust cap comes off. Which I don't think is necessary. It's it's got some kind of a sealed bearing in there, like a Sprague clutch, you know, one-way bearing. Anyway, I would have liked to have replaced the clutch pulley mechanism on the old alternator and just see if that totally solved the problem. But unfortunately, I just don't have time to mess around with that because Mama needs her wheels. I even thought about a way to test it. I was thinking maybe we could just hook up a scope to the output of the alternator and measure the frequency of the ripple, and then put a photo tack on the pulley right here and compare the tack reading to the ripple frequency. So if I'm thinking about it correctly, the output ripple of the alternator should be 3 times the RPM of the pulley because it's a 3-phase alternator. So yeah, anyway, I didn't have time to mess around with all that stuff. I'm pretty sure that's the problem though. I mean, the smoking gun is when we disconnected the control wires here for the alternator, you heard it just quiet right down. And that basically, that turns off the voltage regulator, so it basically collapses the field. And at that point, the alternator is just kind of coasting. And I don't know what kind of torque these alternators, you know, produce when they're charging, but I imagine it's quite a bit. And I'm thinking it was just enough to slip that little Sprague clutch and cause the problems that we were seeing. I also picked up a Continental belt, even though it has a brand new Dayco belt, because that Dayco belt is just way too tight. When I originally installed it, I almost couldn't get it on. And then when I went to take it back off, I couldn't get it off. So I don't want to mess around with it anymore. I'm going to try this Continental belt and see if it solves the problem. Well, I guess we'll go ahead and put this guy in. It's actually pretty easy. I did take the overflow tank for the coolant loose and just kind of fold it back. And I think I can sink this thing right down in here. Oh, this flashlight's acting like it's gonna die. So on this car, it takes a 14 for the big one and a 12 mil socket for the small one. About a half mile of threads on those. Maybe we'll use a little bit of this dielectric goo on the connections here. Except there goes my brush. Great. I should just make a compilation video of me dropping things on camera. Probably be pretty funny. Except nobody would sit through a 2-hour-long video. Okay. Okay, yeah, looking pretty good. Okay, this clip down here did not survive, so I think we're gonna have to zip tie that. Oh, let me get it clear out of there. Toyota loves to use these little clips on all their wiring harnesses, and it can be kind of a pain to get them out. Come on. There we go. By the way, I like to use these pliers for popping those Toyota harness clips out of the brackets. I think these are made by Lyle. They're body clip pliers, but they work pretty good for pinching those harness clips and releasing them out of the metal brackets. Now the fun part, which is the belt. Okay, belt installed, and that Continental belt was way easier than the Dayco. I'm so glad I didn't try to put that thing back on. That was a nightmare. Yeah, slipped right on, no problem. Okay, alternator is in, battery's hooked up, test equipment is ready. Let's fire it up. That's more like it, 14 volts. It was charging 25 amps at idle. We're dropping slowly. Cool deal. Much quieter. I'll let the RPMs drop down here and see how everything looks. But so far so good. Okay, headlights are on, high beam, blower motor on full, and it's still charging the battery a little bit, about 7 amps. Battery voltage is staying good, 13.8. I think we got it. Okay, amp clamp on the actual alternator output. Looks like it's putting out about 42 amps. So nothing wrong with that. Looks pretty good. Okay folks, there you go. Dead battery because of an alternator pulley. And that's the first time I've ever seen that happen. Now maybe it's a common problem on these newer cars, I don't know. I don't work on a whole lot of newer stuff, especially cars. I mean, it seems like a major failure point, and if you ask me, that's a really crappy design. In my opinion, it's not worth the additional complexity, but this is how everything is going these days. And actually, you know, this is a fairly complicated charging system. Like I said, it's ECM controlled, but it's actually getting worse. The newer vehicles are now using like LIN or even CAN bus communication between the ECM and the alternator. And the alternator is basically becoming its own little module. And, you know, the computer tells it to do whatever it thinks it needs to do based on the driving conditions. And the alternator can basically vary your amperage output and voltage output, you know, depending on a huge number of factors. So it's making it very difficult for even experienced guys to diagnose these smart charging systems. So the only consolation I can tell you guys as far as a DIY, you know, troubleshooting or diagnosis of these smart charging systems, as far as I know, on all of these smart charge system alternators, if they lose communication with the ECM, they will default to being an old school constant voltage output alternator. So if you have a situation where your battery's dead or whatever, you don't think the alternator is charging like it should be, find a way to isolate it from the ECM and start the vehicle up. You may get some check engine lights or some funky warnings or whatever, but the alternator should basically function as a standalone, you know, system like the old school, you know, 3-wire alternator that we're all used to. Now you're still going to have to maintain power to the voltage regulator and, you know, all the other circuits in the alternator. You gotta cut that communication line to the ECM. So I did some more testing with this thing that you didn't see on camera. I did do a voltage drop test from the output terminal of the alternator to the positive terminal of the battery. Did the same thing from the case to the negative terminal of the battery. Voltage drop was 0. And, you know, it's pretty obvious that the alternator was not keeping up when we watch that voltage of the battery just keep going down, 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 down. Well, the battery light does work in this car. The battery light never came on during any of these events. It just wouldn't start. Anyway guys, I don't know if it's going to be much of a video, but I want to throw it up there just in case other people have this same issue. Might help you get out of a jam. So thanks for watching.